Am I on? I am. I think I'm on. Hey, so first off, welcome to Microsoft. I'm Scott Levay. I'm the director of the Microsoft Technology Center across the hall. We're sort of, for those that know, we're sort of an innovation and proof of concept lab, primarily focused on our enterprise customers. And so we've had Hive here a bunch of times. These are some of the most fun events that we do, because we actually sort of, it's a good mix of technology, new technology, where we're pushing limits of what, and doing new things, as well as real business applications and business impact. One thing I often sort of talk about what Microsoft's strategy is as we kick some of these off. One thing I want to talk a little bit about, we came up in a meeting we had today with one of the Bay Area's top technology providers, and we were sort of just talking through what our roadmap was going to be in our investments. And we sort of put up with the sort of four mega trends: mobile, social, cloud, and data. And one of the people asked questions of, what do you expect your market share there to be? What are you measuring success in the big data space? How much you plan to sell? And it was an interesting question. It was from sort of just a perception and sort of how we're communicating it. Because at least from my perspective, yeah, we have products in that space. We got SQL Server, we got Parallel Data Warehouse, we have HD Insight in Azure. So we certainly have big data products. But at least from my perspective, we're not really looking at big data as the products we're selling into that market space. We're really looking at it as a table stakes for what it takes to be a technology provider going forward. We're looking at data as permeating everything. So at the SQL Server launch, what, 2.5 weeks ago up in San Francisco, Satya Nadella, our new CEO, was down. He sort of gave the kickoff around that. And he had a great phrase that I think I've stolen in every presentation I've given since then, where he talked about the move to the cloud and what that meant for the industry. And he talked about data being the exhaust of the cloud. I kind of like that phrase. We, as a provider of cloud technologies, we're able to, through the data that comes off that, our usage data, we're really able to take that, harness it, and make our products a lot better. So if you look back at what Microsoft's been doing over the years, we've always been a big collector of data in sort of niches across our products. So even rolling back to the NT Windows 2000 time frame, there were some perceptions true around stability of the NT platform. So we instrumented the hell out of that to find out where it was crashing. A lot of it was in driver code, so we use that to prioritize which vendors we work with to help them improve the quality of their drivers. We looked at that to provide, to prioritize what hot fixes and service packs we would put in, so we knew what was causing people problems. And we said, oh, we're going to prioritize it this way. We did the same thing around Office. We have, when you set up the products, there is a, yes, I want to participate in the consumer experience improvement program or whatever it is. And when you click yes, we get all sorts of data out of that. And so one of my favorite questions to ask is, what do you think the most popular, most used feature of Office across the board is?
Clippy.
I'm sorry, was that?
Clippy.
Clippy. Now, the Clippy was not the most used product feature of Office. Any other guesses?
Search.
Search? So by far, the most used feature of Office is undo. And so, but true. So people would try something, and they'd realize that wasn't what they wanted. And so people would do something, they'd undo, and how do you get these stacks of undo? How do you get yourself back? So that really led to the ribbon, where you can highlight a set of text, you can highlight fonts, you can highlight styles, indenting paragraphs, and you can see what that's tables, and you can get an idea of what that's going to look like. Greatly improve the product. We used data to realize that people weren't able to navigate their way through 1,000 features of Office. The menu structure of Office was awesome when there were 100 features of Word. You could navigate through those menus and find your way. But as Office grew into a bigger and bigger product, you couldn't do that. So we use that data to improve our products. So we're really looking at data being a way that we can improve our products. We can make them better. We can make them more personal. We can make them predict what you're doing. If you look at what we're doing around Cortana, a lot of that, yeah, there's some machine learning in there, but a lot of that is database, because we're able to take broad sets of data and make predictions at a human level of what you're going to want. So that's a lot of how we view data. Yeah, we got products in there. Yeah, we want to have great market share around SQL Server, around HD Insight, around cloud. But I think that it's now, you have to have a big data strategy if you're going to be a technology provider. If you don't have investments, if you don't have that, and you're in the technology industry, you're going to get outrun by people that do. So that's Microsoft's, at least I should say Microsoft's, that's my view of how Microsoft is going to go after the changing marketplace around technology and how we're going to get ourselves engaged. So if people want argue with me, if people want to have different views, at the mixer afterwards, I'd love to have people come after me and give their views on that. And with that, I'll pass it off to Pashu. And so once again, thanks for coming to Microsoft. We appreciate your coming out here for the day. Evening.
Hi everyone, how are you doing?
Good.
We are very excited today at the Hive. Please make sure to stay till the end, really, tonight. You won't regret it. We have prepared something for you. Here's a hint that I wrap. So I'm with the Hive. My name is Pashu Christensen, and I'm managing the Hive think tank, which is a group of practitioners, data scientists, engineers, thought leaders like you. We have over 4,500 members, so it's one of the largest data-driven meetup group on big data in the world. So thank you for being part of it. We have a very busy week next week, so make sure to register. We have 2 events, one on Wednesday, one on Thursday evening. The first one is in San Francisco, but it's worth the drive. If you are driving, just come over. It's going to be around connected cars and telematics, and it will be moderated by Kimberly Gunter from IBM. So please make sure to register and don't miss this one. Then we have the founders of Hadoop the following day. It's part of our Clash of the Titans series. So you can see the names here, the companies' names, and you can guess that it's going to be very busy on stage, very exciting. So make sure to register for that one too. And then we'll have another one on June 4th around mobile and social commerce, moderated by Rob Goldman, who is the head of monetization at Facebook. We'd like to thank our sponsors, especially Microsoft tonight, for supporting us. It's been almost a year now, and thank you for having us here at Microsoft. And Ravi is going to give a very quick introduction about the Hive, and again, we are really happy to have Sriram with us tonight. Thank you.
Thank you, Pashu. So I'm personally very excited. Thank you. I'm personally very excited today because my good friend Sriram is speaking on search, but we'll get to that. First about the Hive. So the Hive is a fund. We fund companies at the seed stage. We are able to engage with very early stage companies, so we'll incubate and launch these companies. And our focus is on not on the infrastructure, but typically on use cases and applications of data. And so many of you met Lance, who's sitting here. I hope Russell will be here later, so you'll have a chance to see Russell, who's also spoken on Agile Data Science maybe about a month and a half back. And so reach out to us if you have any questions afterwards. Those are some of our companies. We've missed one or two here. I'll mention one that we did miss, Perspica. So reach out to us if you're interested in joining these startups. Our focus is on either functional area applications or vertical segments, applications in vertical segments. So we have a point of view very much along the lines of what Scott Morvay just said, which is that data is going to disrupt every vertical segment in the next 5 to 10 years. Obviously, some before the others. And so we are very motivated to help build those companies, work with entrepreneurs to build those companies that will disrupt these different functional and vertical areas. We are looking for some people, and this is in the IoT space. So the first one is someone who's familiar with and has experience with event and message queue processing. And there's a second company that also in the IoT space where we're looking for someone. And this is with someone who has data science background, but coming from the industrial controls and manufacturing side. So reach out to us if you know anyone or if you're interested. The hashtag for today's event is Hive Data, so join us on Twitter. There's going to be some post Q&A entertainment, so the hashtag for that is DataWrap. Be part of the conversation. As I said, I'm super excited to welcome Sriram and Kumaresh from LinkedIn. We'll be speaking about search at LinkedIn. I've known Sriram for a very long time. We grew up as kids, literally across from the street from each other in Kanpur, in IIT Kanpur. And Sriram has since then been, got a PhD at Stanford, worked in a variety of companies, VMware, I'm sure I'm missing a few, VMware, Google, Facebook. I don't know how many of you remember the Harlem Shake that we did with Sriram about a little over a year back. So it's got tons of hits on YouTube. So if you haven't seen it, go tonight to YouTube. Actually follow the Hive channel, Hive Mumble it's called, on YouTube, and go and see it. You'll enjoy it. And so Kumaresh is a product manager at LinkedIn. Went to school at a place where I was born in Urbana-Champaign in Illinois. And I was just born there, he went to school there. And has in the past worked at Microsoft. A lot of good people come from Microsoft. So with that, I welcome Sriram and Kumar.
Yeah, thank you so much. Thank you, Pashu. Thank you, Ravi. And yes, I've known him for 40 years, and it's always exciting when I come and do something with him. Thank you guys for coming. Thank you, Microsoft, for doing this. And I'm going to talk about search and LinkedIn along with Kumresh. I'm going to talk about the heart of search. Kumresh will talk about the soul of search, and then these guys will give us a wrap at the end. All right. So I wanted to start today first with a video. This.
What are you doing?
Social networking.
Social networking?
Everybody's doing it. I have 826 friends.
That's a lot of friends.
Well, I can find anyone.
Okay. I need to put together a team of international finance experts who know merger arbitrage, have 10 plus years experience, speak Cantonese, and can hit the ground running Monday.
I don't have any friends like that.
So this is an IBM commercial, but it could very well have been a LinkedIn commercial. Let me just find my mouse, and then I'll be. Okay, there we are. So this could very well have been a LinkedIn commercial, and this commercial is not meant to make a dig at anybody. It's just meant to show what we need to do. We have a lot of challenging problems in search, and we've done a lot. We've got a lot more to do. We'll talk about today where we are at today, and the product part is going to be presented by Kumresh. I won't say too much about it beyond the fact that we are a search engine. We as a team work on search engines, but we focus on LinkedIn as a full product experience and search as being part of it. Unlike a company like Google, where search is the product, where the goal is to search something, get a result, and get out of Google. For us, search is a little piece of a bigger product. Our goal is to make LinkedIn better, not to make search better. So making search better leads to making LinkedIn better. Otherwise, we're not doing our job. Interestingly, search at LinkedIn is a big part of the LinkedIn product experience, and Kumresh will talk a lot more about that. So I'll stop talking too much about the product right now and go into the infrastructure on which we have built search engines at LinkedIn. I'm going to first cover some history. The first part is going to be up to a year ago, and then the second part will be from, I joined LinkedIn about a year ago, so the second part would be since I joined to today, where we've got. Okay, so like all other companies that aspire to build a small search engine on top of a reasonably small corpus of data, we also use Lucene. We started with Lucene, and we got up and running really quickly. Lucene is, I'll talk about Lucene in more detail. It's an open source search stack. We got it working really quickly, and as we scaled and as we got bigger, we had to do more things, and we had to extend the Lucene. We had to extend Lucene with a bunch of other pieces that we built in-house. All those pieces got open sourced. And you see some of them listed here. I'll talk about them in more detail soon. And then as things evolved, the stack that we built, well, before my time, got adopted for other use cases that were similar, such as recommendations, newsfeed, ads, and analytics, and so on. But we went through growing pains, and we had to redo stuff, and we'll come to that later. Before getting into details, for some of you, you might not have heard of Lucene before or not be familiar with it. Let me give you a quick deep dive on what it is. It's an API. It's an open source API that allows you to build a search engine through the following constructs. These 5 bullets characterize Lucene at a reasonably high level and covers it reasonably in detail. You have a search index, and you get an API to add a full document to the search index or to remove a full document from the search index. You have an API to construct queries, like think of it like a SQL query that you use to query a database. Think of the search index like a database, like that's the analogy. You then use that constructed query to go to the index and find matches, find documents that match your query. And then a bonus that Lucene gives to you is, as it gets you the documents back from that store, from the index, it assigns a score to that document. And the score is essentially how well that document matches your query. And then it just it gives you the bonus of ordering those documents returned in order of score, so you get the best documents at the top and going down from there. So very high level, that's what Lucene gives you. Little more deep dive into what the search index looks like. There are 2 pieces of a search index. There is an inverted index and a forward index. An inverted index is a mapping of terms, typically the terms you search on, to documents that contain those terms or documents that need to be returned if you type those terms as queries. And then a forward index is metadata about those documents that will eventually get returned. I'll illustrate with a small example. So think of an index with 2 documents, one corresponding to Kumaresh and one corresponding to me, two entries in the LinkedIn index, very tiny search index. And then I'm only focusing on 3 terms in these 2 documents, Kumaresh, Sriram, and LinkedIn. All right? Ignore everything else. What you see here is the inverted index. The horizontal lines in this picture represent documents. So you have 2 documents with document ID 1 and document ID 2. The vertical lines here correspond to the inverted index. They are the terms. Kumaresh maps to document 1, Sriram to document 2, and LinkedIn to documents 1 and 2. Those green circles are called hits. So you can say that the term Kumaresh has a hit on 1, the term LinkedIn has a hit on 1 and 2. So very tiny index. Now, once you get that document 1 or document 2 that matches your search query, you need to find out more about that document, and for that you have a forward index, which is metadata about that document. So given a document ID like 1, you can get a blob of data corresponding to it, and you can do whatever you want with that, maybe do some richer scoring or show it as use it to show the search results, and that's called the forward index. So getting into details, those lists that you saw in the previous slide, the vertical lines, mapping terms to documents, are called posting lists. In general, just to give you an idea of the size, the previous example had only two documents and 3 posting lists. Typically, in a LinkedIn index, we have hundreds of millions of posting lists. We have hundreds of millions of documents. A posting list can be highly specialized in that it could contain just a single hit. So that posting list applies to just a single document in an index. Or it could be very general, and it could have maybe 10 million hits. We see both kinds. The terms can be words in the document, or it can be inferred attributes or other kinds of attributes that we figure is useful to add to the index. And I'll show you some examples of this. So Lucene queries. So Lucene has a query parser that takes queries in a string syntax. I'm going to give you a bunch of examples. The query Sriram Shankar with the quotes around it is a query that says, look for documents that have Sriram and Shankar next to it, next to each other, sorry. So it's a phrase query. A query without the quotes, 2 terms without the quotes, is an OR query. So it says, give me documents that contain either Kumaresh or Sriram, or using the picture that I showed you earlier, show me all the documents that are either hits on the posting list for Kumaresh or hits on the posting list for Sriram. Okay, so plus is another term. Plus says it's required. So plus Sriram plus LinkedIn means show me documents that are that contain hits for both Sriram and for LinkedIn. So this would be, for example, my document in the LinkedIn index would match this query. Here is a combination of the previous 2 queries. Plus Kumaresh means the documents have to be in the posting list corresponding to Kumaresh. Then the other term, connection : forwarding 001, is an optional term. It doesn't have to be present, but if it is present, the score that Lucene would assign to that document will be higher. So in this case, it's a funny term, connection colon 418001. 418001 happens to be my LinkedIn ID, member ID. And what connection colon 418001 is in our index, the way we encode it, is there's a hit for every document that I am connected to at LinkedIn. So that's what it means for it. That's how we index it. So Kumaresh, that particular query says, give me all the Kumareshes, but score the documents that I'm connected to higher. All right? Finally, an extension of the previous query, plus Kumaresh, industry colon software, again, the same connection. So again, documents that contain the word Kumaresh in it, score it higher if that Kumaresh is from the software industry, and score it higher if it's a connection to me. You see that last part of that query, the caret 4, it's called a boost. It provides an importance to that term. It says, give it a higher score if it's connected to me. So in some sense, make the score of that result even higher. So it's more important that it's connected to me as compared to being in software. Right? So examples of a few queries. And finally, how does Lucene score? So what Lucene does is, when you do the adding of the documents to the index, so you say add document 1, terms are Kumaresh, LinkedIn, add document 2, terms are Sriram, LinkedIn, and so on. You add millions of documents to the index with millions of terms, hundreds of millions actually. And what Lucene does in the process, it counts all the terms, it counts repetitions of the terms, it counts interesting attributes, it measures interesting attributes of the terms. And in its index, it has some interesting information. Technically, we call it TF-IDF. It also stores the positions of the terms in the document so that it can provide you the phrase query capability. And then in the query, it accepts some scoring information via the query modifications, as you saw the optional part of the query in the previous slide, and also the boost that I showed you in the previous slide. It uses that. And using all of that information, as it gets the documents out of the index, it also assigns a score to it. And at the end of the day, you get a bunch of documents all scored for you. Now the nice thing here is that it is a search engine out of the box. If you have very small use cases, maybe up to a few million documents, you should be probably able to build a search engine in a few hours and have something running that's respectable and get on with it. But you probably will get stuck there and not be able to make it better. Okay, so some of the layers that we added on top of Lucene. Let's take Sensei. Sensei was something built at LinkedIn and it's been open sourced. Now, typical Lucene indices we always like the indices to fit in memory, and our Lucene indices are big enough that they don't fit in the memory of a single machine. So what we do is we break up the index and put a few documents on one machine, a few documents on another machine, and so on. Each of these partitions is called a shard, and we make the search engine distributed across a bunch of machines, each machine serving a piece of the index. Now we need some way of managing all of this, managing the cluster. We need a machine on the top called the aggregator or a broker that talks to all of these shards, sending them the same query, and then getting results back from all of them and merging all the results. All of that is done for you by Sensei. So sharding, cluster management. And Sensei also provides a query language that is a little higher level, easier to use, and it makes it a little easier for you to provide richer queries. So this is a schematic of Sensei. I'm not going to get into this in great detail, but you can see that at the bottom there is the pipeline through which you ingest documents into the index. You add documents that way. This is a 3-shard index, and you can see that the blue nodes, they're the Sensei nodes, they are the machines. In this particular architecture, you have two shards being served, or two shards being served per machine. And then at the top you have the green boxes, which are called brokers, which are the ones that actually send the queries to all the shards, get responses, and then combine them together. Zookeeper is a mechanism through which Sensei manages the cluster, figures out where shard 1 is, where shard 2 is, where the replicas are, where the backups are, and so on. This is an example of the Sensei query language. You can search online and find this yourselves. I won't get into this in great detail. But the idea here is that what Sensei has done is it's taken that Lucene query language that I showed you a little earlier with Kumaresh and industry software and connection 418001 and so on, and translates that into something that looks very similar to SQL. And then at the bottom of it, you have this using relevance function, and there's something that looks like code there. That code is additional scoring that goes beyond Lucene scoring. So what Sensei does for you is, in addition to providing you the cluster management and sharding, it also provides you a higher level capability of querying the index and also adding further scoring capabilities to it. Makes it a little easier. It makes things higher level. Again, when you go beyond that basic capability that Lucene provides, and you want to get to slightly bigger document sets and bigger indices, and you want to do a little more sophisticated querying and a little more sophisticated scoring, Sensei helps you out. Okay, so the next thing that we had to add to Lucene and Sensei is deal with live updates. So, as I said, a Lucene index allows you to build an index by adding new documents and removing old documents. You can only do, those are the two atomic operations you can perform. And there's a thing called the index reader, an object in Lucene called the index reader, through which you read contents from the index. So you provide the index reader a query and it gives you documents back. The index reader only has access to the documents since when it was opened. All the additions and deletions to the index since the index reader was opened, it does not have access to. To get access to everything that was updated since, you need to close the index reader and open it again, which is a costly operation. So Lucene is, while Lucene claims to be supporting live updates, there are some limitations of this kind. The other thing that Lucene has a limitation with is you have to update an entire document in one shot. So for example, let's take my document. In reality, my document in the LinkedIn Lucene index might contain a few hundred inverted index terms. There'll be a few hundred posting lists that match my document, and there'll be a reasonably big forward index. Suppose when I moved from Facebook to LinkedIn, there was a live update where the one posting list, the Facebook posting list stopped having a hit for me, and the LinkedIn posting list started having a hit for me. That is just a single live update, a very tiny piece of update. The only way we can achieve that, make that update happen in Lucene is to take the entire document corresponding to me, delete it, and create a new copy of my document with that one change. So what you need to achieve this is, you need to be able to get access to all those other values other than the company change, all the other few hundred inverted in the posting list that hit my document. Lucene doesn't give that to you, so we have to find a way to fix that. So Zoe is a system that we built to achieve the absolute liveness of the index. So I won't get into details again, but the general idea is that it keeps 2 copies of the most recent live updates, or not 2 copies, it keeps 2 buffers in memory, RAM 1 and RAM 2, one of which keeps getting the latest updates. The other one has the latest updates prior to that, which is being flushed into disk. And when you read, you've got a special index reader that can also read the RAM, makes it easier to, it allows you to have access to documents that are absolutely fresh. To solve the other problem, where you want to make a change to a document where just one field changed, and you need access to the remaining few hundred fields because you need to create a new document with those few hundred fields that didn't change, plus the one field that did change. We had to build an entity called the search content store. The search content store is identical. It contains all the information that the Lucene index contains, but structured in a manner where given a document ID, you can get all the inverted index terms. You can't do that with Lucene. You have to do it. So the way we do live updates is, when an update comes along, so the activity field would contain the change that my company changed from Facebook to LinkedIn. It goes to the content store. The content store can take that incremental change and it'll update itself. And after it updates itself, then it sends a full new document to Lucene saying, okay, add this new document. And it also says, delete the old document corresponding to me. So the content store is a very heavy-handed way of making live updates happen in the Lucene. So a combination of Zoe and content store helps us do live updates. Okay, finally, faceting. Faceting is, in this slide, if you see on the left-hand side, this query, by the way, is people